I welcome you all. In this video, I'm going to solve the problem based on design of knuckle joint. This problem was asked in the university examination May 2015. Now let us go through the problem statement. Design a knuckle joint to withstand a load of 100 kilonewton. All the parts of joints are made up of same material. Sigma ut is equal to sigma uc is equal to 480 megapascal and tau u is equal to 360 megapascal. Use the factor of safety of 6 on the ultimate strength. Now, if you read this problem from the first line, in the first line, the force P acting on the knuckle joint is given, it is in kilonewton, so we have to convert later it in Newton. Then all the parts of joint are made up of same material. So now this indicates that the material of rod and pin is same. Okay, so whatever the permissible stresses that we are going to calculate for rod, same can be used for the pin. Okay, so this is the significance, or this is the indication of this line. Then the next and very important part of this problem statement is that instead of giving notation SUT for ultimate strength, they have given the notation that is sigma UT. Instead of SUC, here it is given sigma UC, and instead of giving notation SSU, here it is given tau U. So we know that this ultimate strength in tension, compression, and ultimate strength in shear is nothing but the failure stresses. Okay, and for such failure stresses, generally we use the notation like SUT, SUC, and SSU. But here the different notations are given. For SUT, they have given sigma UT. For SUC, here it is given sigma UC, and for SSU, here it is given tau U. Okay, so after that they have given the factor of safety, that is Fs 6 on ultimate strength. Okay, so as this material of this knuckle joint here, it is a brittle material. Okay, as they have not mentioned, but still from this property, that is ultimate strength, we can able to understand that the material used for this knuckle joint, definitely it is a brittle material. Okay, so first of all we will write the given data, and in the given data, first of all we will write that instead of using such notation, we will write the notation that we are used to. Okay, so first of all we will replace the sigma ut by SUT, then sigma uc by SUC, and tau u by SSU. Okay, so this is ultimate strength in tension, ultimate strength in compression, and this is ultimate strength in shear. Okay, so P is given 100 kilonewton. So let us convert it into Newton. So multiply by 10⁻³ we will get the force in Newton. Now next is we have to write the for rod and pin, as all the parts are made up of same material. That means the rod and pin are made up of same material. So for rod and pin, SUT is equal to SUC, that is SUT is equal to SUC is 480 megapascal, so that we have to write. Then tau u, instead of tau u we have to use this SSU notation, so SSU is equal to 360 megapascal. So this SSU means ultimate strength in shear, and the Fs is given factor of safety 6. Okay, then we have to calculate the permissible stresses for rod. Now here I have written here rod oblique I oblique fork, because always whatever the material of rod is there, the same material is there for the eye and fork, because rod and eye are not the different parts. The geometry is different, that's why name is given different. Similarly, rod and fork are not the different parts, its geometry is different, that's why the name is given different. Okay, so always the material properties for rod, eye and fork are same, and that's why permissible stresses for rod, eye and fork are always same. Okay, then we have to find out the permissible stresses for pin as well, but as the material of all the parts is same, so that means permissible stresses for all these components or portions of knuckle joint are same. Okay, so common permissible stresses we have to use for rod, eye, fork, and pin. So first permissible stress we have to calculate is permissible tensile stress, which is denoted by sigma t. Now we know that sigma t is calculated as SUT upon Fs. Now SUT is 480 and Fs is 6. So we get the answer of sigma t as 80 Newton per mm square. Now similarly, we will calculate the permissible compressive stress sigma c. Okay, so permissible compressive stress sigma c is given by equation SUC upon Fs. Instead of SUT, we have to write SUC for sigma c, SUC upon Fs. Now SUC is again 480 upon 6. We get the answer 80 Newton per mm square. And the third permissible stress that we can calculate from the given data is permissible shear stress tau. Now the permissible shear stress tau can be calculated using equation SSU upon Fs. Okay, so SSU is given directly here 360. and Fs is 6. So we get the answer of permissible shear stress tau as 60 Newton per mm square. Okay. Remember that in some problem, if this SSU is not given, we would have written here SSU is equal to 0.5 SUT upon Fs. Okay. But here as SSU is given directly, so we have to use this value of SSU, and we cannot use here SSU is equal to 0.5 SUT. Okay. So you remember this point. To solve the problem based on knuckle joint, we required 4 permissible stresses, and this is the 4th permissible stress, that is permissible bending stress sigma b. And as we have discussed in the previous article, which is based on permissible stress, that we have to assume this permissible bending stress sigma b always equal to permissible tensile stress, and already we have calculated this permissible tensile stress as 80 Newton per mm square. So let us put this value here. So permissible bending stress becomes 80 Newton per mm square. So in this way we can calculate the permissible stresses. Now after calculating permissible stresses, we have to design knuckle joint. Okay, so we have to follow the 7th step, and we have to find out the dimensions, and we have to check the stresses. Remember that in this problem, just it is mentioned that design a knuckle joint, which indicates that we have to solve all the 7 steps. Now let us solve the step number 1 of this design of knuckle joint. And step number 1 is calculate a diameter of rod. So as shown in this step 1, for this step, the formula is capital D is equal to under root 4p upon pi into sigma t. So let us write this formula. So capital D is equal to under root 4p upon pi into sigma t. So this is the equation required to find out this diameter of rod capital D. Now let us put the value of this p. So p is 100 into 10 raised to 3. Then sigma t, that is permissible tensile stress, is 80 Newton per mm square. So let us put this value in this equation. So if you calculate this equation, if you solve this, you can get the answer as 39.89 mm. Okay, so from the manufacturing consideration, we have to round up this value, and let us take this value of capital D by adding 2 mm as 42 mm. Okay, so this is the answer of diameter of rod, and we have completed step number 1 of design of knuckle joint. Now the second step is calculate the enlarged diameter of rod, which is denoted by capital D1. So from this step number 2, we can get the equation of capital D1 in terms of diameter of rod. So let us write this equation. So capital D1 is equal to 1.1 times of diameter of rod. So put the value of capital D, which we have calculated from the step number 1, it is 42. And let us calculate this answer of D1. So it is, so answer of this is 46.2 mm. Let us round off this value by adding 1 mm. So answer of this enlarged diameter of rod is 47 mm. Here we are not going to add 2 or 3 mm, because already we have added in this diameter of rod 2 mm. So here it is not necessary to add more dimension into this D1. So with this step, our step number 2 is completed. Now let us move to the step number 3, calculate A and B, where A is the thickness of fork end and B is the thickness of eye end. And from this design procedure, we can write the equation for this step number 3 as A is equal to 0.75 d and B is equal to 1.25 d, where d is the diameter of rod. So let us write these equations. So A is equal to 0.75 d and B is equal to 1.25 times of capital D. Now let us put the value of D in this equation and let us calculate the answers. So here the value of diameter of rod, that is capital D, is 42. So let us put the value of 42 here and here, and let us calculate the value of A and B. So answer for A is 31.5 mm. So let us round up this value to 32 mm. Again here we are not going to add more dimensions because already we have added more dimension in capital D. Similarly, the answer for B, that is thickness of eye end, is 52.5 mm. So let us round off this value to 53 mm. So this is the thickness of fork end and this is the thickness of eye end. So with this calculation we have completed step number 3. Now let us move to the step number 4, and step number 4 is calculate diameter of pin, that is small d. Now from this design procedure we know that in the step number 4 we have to calculate the diameter of pin based on shear stress tau and based on bending stress sigma b. This is the formula for shear stress from which we have to calculate the diameter of pin, and this is the formula for calculating the diameter of pin based on bending stress. So first of all, write for based on shear stress. So first of all we will calculate the diameter of pin based on shear stress. So I have written here formula for diameter of pin, that is small d, which we have to calculate on the basis of shear stress, and this is the formula that we have referred from design procedure of knuckle joint. Now in this equation we have to put the value of P and we have to put the value of permissible shear stress tau. So already we have written in the given data the value of P is 100 into 10 raised to 3 Newton and value of permissible shear stress as 60 Newton per mm square. So let us put this value here. So under root twice into 100 into 10 raised to 3 upon pi into 60, and let us calculate this value of diameter of pin. So if you calculate this answer you will get answer as 32.57 mm. Okay, now let us calculate the diameter of pin based on bending stress. Now in order to find out the diameter of pin d, small d, based on bending stress, we have to use this equation from the design procedure, that is from the step 4 point number 2. This is the equation that we have to use so that we can get the diameter of pin small d. So now let us write this equation. Now in this equation P is nothing but the external applied load, it is 100 into 10 raised to 3 Newton. This A is nothing but the thickness of fork end, which we have calculated in the step number 3, that is 32 mm, and then this B is the thickness of eye end, it is equal to 53 mm, and this sigma B is nothing but the permissible bending stress, which we have assumed equal to permissible tensile stress, that is sigma B is equal to 80 Newton per mm square. Now let us put this value here and calculate diameter of pin small d. Now I have used the value of P here, value of A 32, value of B 53, and value of permissible bending stress as 80, and this is the cube root. Now let us solve this equation to get the value of small d. So answer for diameter of pin based on this bending stress is 53.39 mm. Now we have to select the maximum value of diameter of pin out of these two values. So if you compare this value of pin based on shear stress, it is 32.57, and diameter of pin based on bending stress is 53.39. So the maximum out of these two is 53.39. So we have to select this. So therefore we have to write one statement like this. Therefore we have to write one statement selecting the maximum value of small d from above two values. So from above two values the maximum value of diameter of pin is 53.39. So therefore the diameter of pin small d is 53.39. Let us round off this value of diameter of pin. So let us select the value of diameter of pin as 54 mm, and we will use this value of diameter of pin for further calculation. So with this calculation we have completed the step number 4, that is calculate the diameter of pin small d. Now the next step is step number 5, calculate DO and D1, where DO is the outer diameter of fork and eye and D1 is the diameter of pin head. And this DO is given as twice D and D1 is given as 1.5 times of D, where D is the diameter of pin that we have calculated from the step number 4. So now let us write these equations. DO is equal to twice D and D1 is equal to 1.5 D. Now let us put the value of small d as 54 mm in these two equations and calculate DO and D1. So after calculation, we will get this answer of DO as 108 mm and answer of this D1 as 81 mm. So this is the outer diameter of fork and eye, and this is the diameter of pin head. So with this calculation we have completed step number 5.